In this video, we're going to look at a more in-depth example of adding two vectors. So we've got vector A here and vector B, and they create a 23-degree angle between the two, with vector A having a magnitude or length of 8 centimeters, vector B with a magnitude of 3 centimeters, and we want to sketch the resultant vector, vector A plus vector B. Well, just going from our two terminal points and connecting those, that's not the vector that we're looking for. Vector A plus vector B means that we take vector A here from the tail to the head, and then we're going to have to add vector B starting from the head of vector A and going out to the head of vector B. So we're going to have to take this vector and move it up here. So we'll simulate this vector here. Let's change color. Okay. We're going to move that vector right here. Okay, so now we've got vector A here, and now we've added vector B to the end of vector A. Well, the resultant vector, A plus B, is going to be from where we started here, at the tail of A, out to the head of vector B. So now we've got A here, B here. B has magnitude of 3 centimeters, and our resultant vector is going to go from here out to here. Okay, so this blue vector here with our tail here and our head here, that represents our resultant vector, A plus B. So now, let me just copy these. Now they want to ask, what is the magnitude of vector A plus B? So this was vector B once we've moved it here to the end of A. And now our blue vector here, that is vector A plus B. We want to find the length of this new vector here. Well, we don't have a right triangle, so we're going to have to use either law of sines or cosines. Now this 23-degree angle that we had to start doesn't help us with this angle at all. But once we placed vector B here, it's in the same direction as this vector here. They're the same. They were equal to each other. So that means that these two vectors are parallel, and we've got same side interior angles here, which means they are supplementary. So if this was 23 degrees here, then this must be 157 degrees. Okay, so we've got 157 degree angle there, but we don't know this angle, we don't know this angle. So since we only have one angle, we can't use law of sines, we have to use law of cosines. And we know that we've got a side here that's 8 centimeters. This side is 3 centimeters. And then we'll just call, just for simplicity in our equation, we'll just call this x. So we've got 8 centimeters here, 3 centimeters, and the side across from the angle, 157 degrees, we'll call x. So we can set up x squared equal to 8 squared plus 3 squared minus 2 times 8 times 3 times cosine of our angle, 157 degrees. Now remember that the 8 and the 3, these two sides that we're using that aren't across from our angle, it doesn't matter which order we put these, we'll get the same answer regardless. So I would have to go ahead and type all of this into my calculator. I would press enter, but I still have x squared, so then I would need to take the square root of whatever my answer is here, We'll get approximately 10.8 centimeters, depending on how many decimals you want. So the magnitude of vector A plus B, right here, the length is about 10.825 centimeters. Now, we want to find the angle that vector A plus B makes with vector A. So vector A was here. I've got these two vectors. I shrunk this earlier, so let's get this back to scale. Vector B is up here. Okay, so now they're asking for the angle between A plus B and A here, those two vectors, so that's this angle here. So we know it's definitely smaller than 23 degrees. Well, we had 157 degrees that we found for this angle right here. We know that we've got 3 centimeters here, and we've got approximately 10.825 centimeters here. Okay, so we've got all 3 side lengths. We've got one angle. We're trying to find this other angle here. So we could set up law of sines or cosines. We're going to have to use this value in either equation. So you're going to want to make sure that after you answered this problem that you've got the exact decimal as the last value in your calculator, so that you can use the exact value in these equations. We don't want to round and just use 10.825 because our final answer may be off a bit. So if we do law of sines, we're trying to find this angle here. So we would have to use the side across from it, which is 3. So sine of some angle x or theta is over 3. And then the other angle we know is 157. So we do equal to sine of 157 over the side we just found, 10.825. Again, use the full decimal here, not the rounded version. Or we could do law of cosines, where the angle we're trying to find is the angle we use. And since the side across from it is 3, that is this value here, and we have to use 8 and our 10.825 values here. Either way, we get an angle of approximately 6.2 degrees, and we knew it was going to be less than 23, so that sounds like a good number.